I've rewritten our expression for t prime of t, and we're going to go ahead and do these derivatives. Now, this derivative is going to be rather straightforward. This derivative is really the only one that requires a couple of steps. And I'm going to apply the chain rule. I'm not going to write out the details of applying the chain rule. This is something you really need to know. And if you don't know it well enough, you need to go back and do some exercises from first year calculus. We have a square root function of some function of t. We should know then that the derivative of that is going to be 1 over 2 times the square root of that function, just knowing the derivative of a power function, and this being a power 1/2 function. So we're going to have 1 over 2 times the square root of this expression, multiplied by the derivative of 9 plus 16 cosine squared of omega t prime. Now, I'm seeing a lot of indications from people who've had a year of calculus that this might be kind of mysterious. Even after a year of calculus, please review if necessary. Okay, now this expression is locked in. We just have to take the derivative of this. Well, let's digress a step further and just write down off to the side here someplace that the derivative of this, well, 9 is a constant, so really we've just got to take the derivative of the cosine squared of omega t, and the derivative of the cosine squared is what? It's the 2 cosine of omega t, because the derivative of the squaring function is double that function, multiplied by the derivative of the cosine of omega t. And we're familiar with the derivative of the cosine of omega t. It's just negative omega sine of omega t. So we end up with negative 2 cosine omega t sine of omega t. So the derivative of 9 plus 16 cosine squared of omega t, 9 is going to give us 0. 16 times this is going to give us 16 times this. And we can now write out our derivative of this expression, and the expression is not written correctly here. Let me kind of obliterate that, and it's the derivative of this entire expression. Okay. So what do we get? We get 1 over 2 times the square root of 9 plus 16 cosine squared of omega t, multiplied by the derivative of this, which we've seen now to be negative 32 cosine of omega t sine of omega t. Putting this together with this, we can fairly easily write down our derivative. T prime of t is what? The derivative of this, which is negative 3 omega cosine of omega t I minus 5 omega times the sine of omega t j, multiplied by this square root, and I'm not going to write out the details of the square root. Anytime we see a square root in this expression, it's going to be the square root of 9 plus 16 cosine squared omega t. So there's the first part of our derivative. The second part, we're going to take the derivative down here, and I'm going to distribute a negative sign also, and I'm going to end up with plus 3, well, sorry, we're not going to take the derivative, but I am going to distribute the negative sign. So we end up with 3 sine of omega t times I plus 5 cosine of omega t times j, multiplied by the derivative of this, which is this, and we're going to write that as, I'm sorry, I got the wrong thing here, minus 32 cosine of omega t sine of omega t divided by 2 times the square root. And again, I'm going to use the abbreviated notation for that square root. All divided by 9 plus 16 cosine squared of omega t. Now we still need to collect the terms of the numerator, and the denominator is, I've left something important out here. This is negative 2 omega cosine of omega t, and there's no good way to work that in except to say negative 32 times omega, negative 32 omega here, and we'll correct that when we write the entire expression out and make sure the units of the expression work. We'll note that we have a factor omega here in this part of the numerator, and now we have a factor omega in this part of the denominator. That's going to be important because the dimensions of this term need to match the dimensions of this term. And if we don't have the omega in this term, we're not going to match the dimensions, which is actually how I went back and saw that I was missing something. I noticed that the dimensions of this term are not going to be the same as the dimensions of this one. So hopefully my error, my oversight here, my temporary oversight fortunately, might be a little bit instructive.